I built a new learning script and I want to share the results with you. This is the overall results across all runs, but we'll come back to this here in a moment. This is what a single run of a model's run looks like. It is a little bit disappointing. You can see this faint burgundy colored line. It's pretty flat. This was actually with Sonoma Sky Alpha. Here's another run with it. The different runs, and this is pretty flat too, as you can see. But I've tested other models. We're going to take a look, and we're going to take a look at the code too and what this does, because this works on some more complex math rather than the spaceship Titanic dataset. The differences between the runs are mostly signified by how many training rows we use per run. For example, this was 50 and this was 100, but they were both pretty flat. We can look at GPT-5's results, for example, here. So we can see some improvement. Now, I did say this was a bit disappointing, but actually, the overall, like if we ask the question, does the model actually learn? We can actually say yes, because by random chance, the results should be 25%. So almost all of them surpass that. And if you look at these accuracy summaries, there is the percentage. We were able to achieve up to 47%. So that's double the random chance. So that's pretty good. But I don't, what this is supposed to be a in context dynamic learning algorithm, right? The system that I wrote. I just wasn't able to see that as clearly as I would like. Here is another result with GPT-5 Mini. You can definitely see clear uptrend. Okay, so we should actually talk about this all runs graph, which really gives us the clear idea. But let's talk about the code real quick and what it generates and what we are dealing with. By the way, all the code files, everything you see here will be available at my Patreon. Link to that will be in the description and the comment, depending on where you're watching that from. Take a look at that if you're interested in this project. So we are actually creating this data set, the complex data set, which takes in five numbers and produces a categorical output from 1 to 4. So these scripts are numbered in progression. Let me zoom in a little bit. One, two, three, four, five. I'll talk about each. So we are creating 10,000 rows of A, B, C, D, E numbers, each of which then equate to an output, 1, 2, 3, or 4. And the output is calculated in a complex fashion because we want to make it difficult and then see if the model will be able to figure out the underlying mechanism which produced this data set. For example, if we sum up the first pair, get the product of the middle, we modulo the last, and we have a weighted sum. And then we go through some if else statements to produce the returns, the categories. So this is the mathematical logic behind it, and it's pretty complex. So I'm not surprised that the models didn't achieve like 80, 90% on it. But my first attempt was actually to give ChatGPT, GPT-5 thinking in ChatGPT, and I linked to that chat if you want to take a look. Essentially, I gave it some example rows. Let me show you by bringing it here. I gave it some example rows and I asked it to write a Python script that takes in five numbers and predicts the outcome. And it actually went ahead and did some machine learning on it. And then normally this is not what I'm looking for, right? I want the model to be able to solve it with just thinking alone, but I wanted to see, entertain this possibility and return this complex script with coefficients and all of that, which is interesting. So this one is the ChatGPT predictor. We can actually run this and we can see that the class accuracy, the overall accuracy is 57.33%. Actually, it was good. This is really quite good. But as we saw in the ChatGPT dialogue, that it used Python and machine learning methods to do that. So next, then I actually build a machine learning algorithm to solve this. Let's actually run this while we talk about it. This one uses multiple different estimators, including XGBoost, random forest classifier. It applies all of them, and then it picks the best one, the best accuracy. So this is a pretty complex machine learning algorithm that actually is going to achieve something like 95%. So it still cannot achieve 95%, but at least we know that machine learning can figure this out. So that's interesting. But our goal is to actually get a large language model to figure this out, and we wanted to figure it out in natural language, right? Just like this. We want it to create the predictive rules as written here, and then we want it to use these rules to predict in return. So these rules actually become its prompts. So different accuracies are achieved like this. So this prompt achieved 22% accuracy, for example, and this one, it's a very long and complex one, apparently achieved 48%. So that's the idea. So that's why, and here this machine learning algorithm is about to be concluded. That's why I wrote adaptive sampling prediction, which allows you to test any model using Open Router or OpenAI, depending, it doesn't matter. You can pick how many training rows you want to use, and you can set your accuracy threshold and make iterations. The script will stop either if it reaches accuracy threshold or makes iterations. Validation row here is done at the end, so that's not that big of a deal because we actually want to test it ourselves with this test rule accuracy. Um, in any case, so this is the script that actually looks at the data and generates rules that looks like this, saves them, and then in the next iteration makes another API call to get the results from the model, and then measures its accuracy, and then feeds it back, asking for improvements. Therefore, that's how we are able to produce this accuracy progress and also save them to accuracy metrics JSON. So idea is to actually try to get a model to learn iteratively by looking at, in this case, for example, at 50 rows at a time out of this 10,000 row data set and come up with a decent algorithm because each one of the rows use the same algorithm, a quite complex one, nevertheless. So that's the idea. And the predict from LLM rules, then you can actually copy any one of these rules, like you can copy its path or relative path and enter it here. We can actually try one. Let's try one. The best also, we save each rules iteration. We also save the best performing rules. Like we can actually pick the one that performed 50% according to GPT-5, and then we can bring it here and paste it. And so this will be the rules, and the rules look like this that the GPT-5 produced. So this is going to be the prompt that we're going to be using. And then we can also pick the model to do the predictions. We can actually just run this. So this is going to take a moment. And this will sample 50 size 50 rows from the data set from random locations. So this is just a quick test to see, if you sample 50 random data points from around this data set, how does the model compare? And the results of those, which are saved to here, as you can see, the highest one was actually GLM 4.5. Interestingly, if you look at this graph, GLM 4.1 did all right. I was surprised. As you can see, it actually achieved higher and higher, larger accuracy, but that is to be expected. I would like to see this brown or burgundy colored line to go up, and it maybe seems to. But this is still an area that I'm exploring. Obviously, there's quite a lot to consider. But GLM 4.5 did well, but it wasn't following the instructions so greatly. It was failing a lot to return the result. It's a good model, but it has its limitations. And I also have this script which plots all of the accuracies, which is the all model accuracy comparison. Maybe we can talk about this. Now, this actually plots all of the models. You see these really faint lines in the back, all of the runs that I've had, which were quite a lot, maybe several dozen, and maybe 2 dozen, and then it smooths them out. And then it also averages them in this black line, this dotted black line is the all entire averages. So what I was looking for here is to see if I would like this to increase. If this were to increase, it would give me hope that learning is taking place. And we can see it in some cases, like here. I believe this was the ZAI, which is the GLM result. You see this peak? And if you look at this blue one, I don't know which one that is. That is GPT-5 mini. In the beginning, see, until about the 75th iteration, there seems to be an upwards trend. Okay. But then it dips. And we see that here too. If you look at this dark blue one, there's an increase and then a dip. But a lot of times it seems to be pretty flat. If you look at this black line, though, we see like here it starts about 38% or something, and it seems it steadily increases up to about maybe 45%, and then it starts dipping. So maybe that's a phenomenon I need to consider. You don't want to feed in too many rows at a time. Obviously, I did a lot of experiments, but I don't know why this drift happens because you can see this in almost all cases, like a little bit of an upwards trend and then downwards. Yeah, this one is still predicting and test rule accuracy. I also, so the interesting thing is that if you look at these rules, these are written in natural language, but you can ask Cursor or ChatGPT to actually convert it into a script. See, just like this, and you can actually run this as well across the data set. I believe that's what we're doing here. Oh yeah, it's actually regenerating the data set, which is fine. It's easy to generate using the same rules, using the calculate complex output. So we can actually run this just quickly, test rule accuracy, and it gives you some kind of accuracy. So there's two ways to use these predictive rule sets, right? One is to use it as a prompt and let the model to do it, or to convert it into a script and do it more deterministically like that. Because the model, if you run the same prompt via the same model multiple times, you're going to get different accuracy values. For example, I am actually working on a new version of this, which is an interesting one. This is maybe this one has more hope. As you can see, it already shows more hope. But this is another project. So this is something that I'm really interested in exploring, and I hope you find it exciting as well. Like I said, all this summaries and everything will be available at my Patreon if you want to take a look at it and modify it, make it your own, try new things. This is the whole script. It's about 1,000 lines that actually does all this. I will create a detailed README file here and put it online. Patreon, you can find the link in the description or in the comment. Also, I have over 400 such projects at my Patreon. And as a paying member, you will have access to all of them, plus exclusive videos and weekly meetings and Sundays. Next one is actually tomorrow. Today's Saturday evening for me. And I also offer consulting services. So take a look at the membership options if you're interested in speaking with me. And thank you for watching and see you in the next one. And I believe this predictions are done. Yeah, that's right. It's still going, but you can see in the first one we got 36%, 18 out of 50 right, and yeah, two of the API calls failed. So this can happen. That's when the model doesn't return the results in the expected format. Now you may say, why aren't you using structured outputs? Well, because not all models follow that, and I wanted to be able to test different models. Most of the time, this actually works. I mean, this you can also consider this is a little bit of a test on the model's instruction following. Most models do well. Interestingly, GLM 4.5 did really well as far as its mathematical prowess, but it did not do so well in instruction following, as in it was failing like this. Usually, this rarely happens with GPT-5 Mini. I'm not sure why this happened, but anyway, so this would have printed. It's still going, but the accuracies and then save it like this. The maximum accuracy we were able to achieve was 0.472, which actually came from JLM 4.5. Again, the next best one came from that, and the fourth best one is still JLM. Kimi K2 next, interesting, and GPT-5 did 34%. Yeah. So it is what it is. So thank you for watching and see you in the next one.